Alright, let's start with this very question. 90 centimeter cube of nitrogen gas sparked with 40 cm cube of oxygen to produce nitrous oxide. What is the volume of the residue gas? So this is the nitrous oxide, which can also be called a laughing gas. The first thing I'm going to do is to balance the reaction. Since we are looking for the residue gas, it simply means the volume of the unreacted gas plus that of the product. So let's look at the balanced reaction for this. There are two oxygen gas in the left side. In that case, I'm going to place a 2 in the front. Okay, just to balance these two in the right side. Then for nitrogen, there are 4 nitrogen in the right. So to place a 2 here has balanced the reaction. In that case, here is the combining volume 2:1, okay, and that of the product, which is also 2. So let's look at the volume before the two gases sparked. This is the supplied volume. I want to call it supplied volume, even though in your exams you do call them given volume or volume before sparking. So 90 is for nitrogen, oxygen is 40 centimeter cube, and before sparking we don't have anything in the product side because they have not reacted. Next, we now look at the reacting volume, which I want to call the useful volume for my own side. In your book, they used to call it the reacting volume, but I want to call it the required volume because that will make sense if I call it the required volume. And here is the reacting volume for your book. Okay, now how do I get this required volume? I have 90 cm cube supplied for this reaction. So what is the exact volume I need to do this combination? Let's cancel this 90. I will now say for me to get what should be under 90, okay, 40 times 2, then divided by 1. That will give you the value that is supposed to do the reaction, or that's supposed to spark with oxygen. In that case, 40 times by 2 divided by 1 will give you 80. So here is 80 centimeter cube, which is the required volume for the reaction to take place. So let's go to oxygen. What should be in this box? I'm going to cancel 40 just the way I cancelled 90 in the previous one. If you cancel 40, 90 times 1 divided by 2, that will give you the required volume for the sparking to take place, or for the reaction to happen. So 90 by 2 is 1 divided by 90 by 1 is 90 divided by 2. That will give you 45. So what about for the product? The reacting volume is exactly the one that has the same mole ratio with the product. So 90 is what we have. Therefore, here should also be 90 cm cube because nitrogen and oxygen and the product have the same mole ratio. Some questions they will not have the same mole ratio. Just stay in on this video to see how to answer the questions like that, or questions like that. Now let's look at what is going to happen here. 90 cm cube and 80 cm cube. We need 80 and they supply us with 90, which means they gave us excess nitrogen gas. Okay, we need 80, we are given 90, which means nitrogen was supplied in excess. So if they ask you which of these gas is in excess, the answer is nitrogen gas. Okay, and which one is the limiting gas? That may be your question. It must not be the calculation part here. It could be the limiting or the excess reactant. So in this case, we need 45 and they gave us 40. That means they supplied us with something lower than what we want. So the limiting gas or the limiting reactant is oxygen. So here we don't want to do anything with this value because it's undersupplied. 90 minus 10 will give you the excess gas given, which we call the unreacted one. This 10 cm cube will not react because it is more than what we want. So if you combine it with the product, that will help you to find the volume of the residue gas. The volume of the unreacted gas plus that of the product will give you the volume of the unreacted gas. So let's put that down. Unreacted gas plus the product, that will give you the volume of the residue gas. Keep in mind, you may be asked to find the volume of the unreacted gas. So the answer is just 10. But for the volume of the residue gas, you have to combine both the unreacted and the product. In that case, 10 plus 90 is 100 centimeter cube. And that is it for number 1 question. Let's look at the second question, number 2. 45 cm cube of hydrogen sparked with 20 cm cube of nitrogen at 200 degrees Celsius and 1 atmosphere. Okay, so let's write the balance reaction. Hydrogen sparked with nitrogen gas to produce ammonia. This is a Haber process to produce ammonia gas. Okay, so now look at this. If you look at the right side, I have 2 nitrogen in the left, and in the right we only have 1 nitrogen. So let's start with nitrogen. Placing the 2 here has balanced nitrogen in both sides. But the effect of the 2 is that 2 times 3 will give you 6, which means that hydrogen has to be 6 in the left. Placing 3 will make it to be 6, and this is a balanced reaction. So let's start with the reacting volume, or yes, the volume that we will say is combining volume. Here is 3. The 3 is to ratio 1, and that is ratio 2. So that's the combining volume. Next one is to look for the volume before the spark. Notice that these ratios are not the same thing. So you have to be careful in this kind of question that no one corresponds with that of the product. So the combining volume has already been given. So this is the volume before sparking. And that volume is 45 for hydrogen. We have a 20 cm cube for nitrogen. And remember what I said. Since they have not reacted, there is nothing in the product side, so product should be blank. So that's the volume before sparking. This temperature and the pressure are constant, so you don't need them to solve any question on Gay-Lussac's law. So let's continue. So what is the reacting volume, which I normally call the required volume? So what do I say we should do before? For me to get what should be under 45, remember I said you should cancel the 45 and use 22 times 3 divided by 1. Alright, let's do that quickly. The number that should be in front of for ammonia, we don't know it yet because no ratio balance or no more ratio is the same thing as that. So let's cancel 45, multiply 3 by 20 and divide it by 1. That will give you 60. Okay, so let me do that again. For me to know what should be under this place, 20 times 3 is 60 cm cube. So because I cancelled the 45 and do the cross multiply, let's do the same thing for this side. I will cancel 20 and say 45 times 1, then divided by 3. So always cross multiply, and that will give you 45 times 1 is 45 divided by 3 is 15 cm cube. So now, if you look at the right side, you cannot tell if you are going to carry 45 or 20 because they don't have the same mole ratio. So I'm going to think of the one that is undersupplied. Just note this: the one that is undersupplied is what I'm going to use to find what should be what should be in the right side for the reactive volume. I said the one that is undersupplied, which is this one. Remember that we need 60 cm cube to solve the question, and we are given 45, which means hydrogen gas is the gas that is limiting reactant, because we needed 60 and we are given 45. So this is the limiting reactant. For this one, we need 15 and they gave us 20, which means this is the one given in excess. So the excess reactant is nitrogen and hydrogen is the limiting reactant. Just keep that in mind. And I said for me to solve what should be under ammonia, which is the product side, I need to focus on the one that is undersupplied. In this case, hydrogen. I don't want to worry about this one for that. So let's use this one for us to know what should be under ammonia. So I said 3 to 2 is the ratio. So 45 should give you what? So 45 times 2 divided by 3. That will give you what should be under ammonia. 45 times 3 times 2 is 90. Okay? And 90 divided by 3 will give you 30 cm cube. That's it. Let me write it out. 45 times 3 times 2, sorry, then divided by 3. So I use the one that is undersupplied to solve for the product if the ratio is not the same. Okay, now I don't need this undersupplied one again to do my continue my mathematics, because 45 is less than 60. We don't have to worry about that part for us to know the gas that is unreacted. So the volume of unreacted gas is the difference between 20 and 15, and that's 5. Okay, the reacting volume has to be smaller to the given volume for you to get the unreacted gas. So this is the product, which is 30. So the ammonia is 30 cm cube inside the container. In this case, you are asked to find the volume of the gas after reaction, which is also referring to the residue gas. It is the sum of the unreacted gas and that of the products. So when you get such question, total volume of the gas, it means the volume of the residue gas. So 5 plus 30 will give you the volume of the residue gas, which is 35 centimeter cube for this question. Number